Okay, hello. So let's talk about impact and complex state management in React. First of all, no tools are silver bullets. So is impact something you would be interested in? Well, if you're like me and you have experience building rich, complex single page applications that doesn't really care about server side rendering, um, it it's more about mounting an application in the browser, and it feels more like a native experience, like you're reaching more for a native experience. It's not that critical that it instantly displays. Maybe even use a service worker to cache the whole application to get that instant feel. But at the end of the day, it's about installing and running an application in the browser. And typical examples of this is like editor types of experiences. You could extend that to things like project management types of applications. And what's a shared challenge with all of these applications is that they have a lot of state management. It's an overwhelming amount of state management as opposed to data management. So if you have experience with that, I think you'll find this interesting. And the first thing we're going to talk about is reconciliation and observation. Now, reconciliation is a pretty amazing thing. It allows us to express UI as a simple function. And UIs, they are dynamic, so we need to express that dynamic behavior. And with a reconciler, this function will be called again whenever any of the dependencies, in this case the props, change. And that means that we can use just normal JavaScript to express the dynamic behavior using if statements, switch statements, we can map over arrays, and so on. And a huge benefit for this is that we can use TypeScript out of the box. TypeScript understands all this dynamic behavior and gives you the correct typing and helps you avoid edge cases and issues. And I think this is really why we stay with React. Like, it's very interesting and exciting to see things like suspense and server components and all of this stuff. But this is why we stay with React, because everyone else, they have their own custom template language or JSX UI primitives to manage this dynamic nature of the UI. And what happens is that you have to learn them, first of all, but they're not tied to the language. So things like typing very quickly breaks down. But when it comes to state, reconciliation isn't that great, right? Because the reconciler was initially introduced to manage the dynamic nature of UIs. And it's really great at doing that and gives an amazing developer experience. But as we moved to function components, they needed to have some kind of state. And the only way to really introduce that with a reconciler is to have the concept we know as hooks. Now, this creates friction, right? Because when we think about managing state, it's an overhead to think about this component function being called again and again and again. And at the end of the day, these hook primitives for state, they weren't really introduced to do state management. They were introduced to do state synchronization. So the example I'm showing here with the data fetching, it's really not something you should do in React, because it's a side effect. You should rather use use effect to subscribe to external state and then update the internal state of the component. But if we look at observation and user interfaces, it kind of flips around. As I already mentioned, if you use observation for building UIs, now you need these special primitives, because now the function that defines the component, it won't be called again and again as the dependencies of the component changes or updates. So you need these special primitives that binds to these observable values so that you can react to them and change the UI. And that means that you need to learn these special primitives, and they don't play well with TypeScript because it's not JavaScript anymore. It's some custom language. But when it comes to state, observation is amazing. Like, you're not tied to the component anymore. You can define these observable values wherever you want, really. Globally, in a context, or even locally in a component if you want to do that. Another thing is that you can now also observe other things that are being instantiated, like a promise, for example. And that's very exciting, thinking about React 19 and the new asynchronous patterns introduced there. So as a conclusion on this, I want to state that reconciliation is amazing for UI, but when it comes to state management, it's not the mechanism we want. But when it comes to state, observation is amazing for that, but it's not really good at UI. So why not use reconciliation for UI and use observation for state management? But that's not the whole story, right? This is only about the primitives and how they're consumed in components. What about defining these primitives? Where do you put your state management? And there are really three aspects of this. You have the local scope, you have the context scope, and you have the global scope. Now, it is technically possible to define an observable within the scope of a component, but it doesn't really make sense, does it? Like, you probably just think now that why you could just do this with useState, and you're perfectly right. When it comes to the scope of a component, the reconciler is so fast to reconcile a single component that it makes absolutely no sense to use observation there. Like, there are solutions that hacks React and actually binds observable primitives to the elements you return, like the H1 here, for example, but it doesn't, that's not where you do your optimization. So I want to state that we don't care about observable primitives in a local component scope. You just use what React offers. But then we have context. And the context scope is actually really important. And the reason it's really important is because it can take props. So you can have dependencies to state, and then you can use that state and wrap state management around that state. And as we can see here, we can make that state observable and expose it on the context to the nested components in React. And then we have global scope, and global is also good to have. But global scope basically means it's state management that doesn't rely on other state. And we're going to talk more about this. Because what typically happens if you take the journey of friction, like we start on the far left with components, we define state within the components, and we start passing that state down as props. And then we need to pass that state multiple components down, and we feel a lot of friction with that. And then we move over to contexts, and we try doing that, and we're happy. Like, we have this one context, and all the components can consume from that. But then you have performance issues, because the value of a context represents state. So for the consumers to update, the context value needs to update, and it will update regardless of what state is being changed and what is being consumed. So what happens is that we start splitting up our context for performance reasons. And And then that becomes a friction. And what we do next then is go global. We create something around React and we consume it directly, and we are happy. What I've experienced is that when we move from context to global, we tend to completely remove the context. But there's something good about contexts. And to put that into perspective, let's talk about what's not good about global, the global scope. So the global problems is that when you choose a global state management tool, it often brings with it its own paradigm. Even Redux does this. Like, you can say that Redux is functional, but when it came, nobody really cared much for reducers, right? And it was, on one side, it was really cool to see how Redux showed that a reducer is a very fundamental concept that can be used to actually do state management. But on the other side, it's very different from what we're used to and what's like intuitive to us. And then you have like these even more technical concepts like thunks and how do they actually work, and how do you do certain things like subscribing to something, where do you put the disposer in a Redux global state store, and so on. And then you have other solutions like MobX, but MobX brings along an object-oriented class-based paradigm where you do mutation on your observable values, which is completely contradictory to what React wants you to do. So often they bring their own paradigms, and making that shift between the paradigm of components and the paradigm of your global state management, that can be rough for some teams. I remember working at Code Sandbox, where we had Overmind, which is a previous state management tool I worked on. And it also was using mutation like MobX. And I saw that the team members, they were always using spreading on arrays and like doing what they would do in React. And it's not a problem technically, but there's a mental shift that's not happening. Another thing about global state stores is that you need to define, and this is especially true for state trees, is that you need to define all the state of the application, including the uninitialized state. And from one perspective, this is amazing, right? Because you can look at this one tree, for example, in a debugger, and you just see all the state, even the state that's not initialized yet. An example of that would be like a user. Like, you don't have the user as the application starts. It's something that comes in from a session asynchronously or something. So what you do is that you define that as null initially, and then you'll populate it with a user as soon as that user is available. The problem is with typing, because now you have a state value of a user, which can either be null or it can be a user. So in any context you're consuming that user, you have to tell TypeScript that the user is actually there, because TypeScript never knows if it's actually there. So you might find this in your code as components using if statements where they are just returning null. It doesn't, like, you know as a developer that the user is always available in that component, but TypeScript doesn't know that because of this. And the same is for any actions or functions or methods you're running to change the state. Another aspect of this is the lack of transient state management. And this, like, transient, it's a fancy word. It just means temporary state management. So where you find this is often where you want to, for example, edit something. Let's imagine you have like a project management application. You have a ticket and you want to edit that ticket. There's a lot of complex state management around that, but it's tied to that specific ticket. So in global state management tools, you typically define like state for editing a ticket. And then as you're editing the ticket, you populate these fields. But when you stop editing that ticket or you change to another ticket, you have to update these fields. And that's a problem because that can cause leakage of state. So maybe you forget to reset or update a field, and suddenly you have some state from the previous ticket on the new ticket. So to summarize this, like the itches summary is that dynamic UI is best expressed using reconciliation. I personally have no doubt about that because we can use just the language. There's no question of what's happening. There's nothing to learn as a JavaScript developer because you're just using the language. Also, it works perfectly with typing. And then state management is best expressed using observable primitives. I'm personally not in doubt about that either. The question is just how do you, like, what's the API and how do you organize these observable primitives? But using them, you will never have performance issues because the components will only reconcile based on the observable primitives they actually consume, regardless of how they are organized. And they allow for us to detach from the reconciliation and actually define state management in a much more natural way than what you would do within the reconciler. Now, what we want to avoid going global is, or choosing a state management tool, is that it introduces a new paradigm. It causing typing issues, as I mentioned, with uninitialized fields, or that it is in risk of leaking state, as I mentioned with transient state management. So I'm not going to go like deep into impact. I'm just going to state that this is what impact is trying to resolve. And the way it does that is that it isn't only a global state management tool. You can think about impact as a set of stores, and these stores can be tied to a context in React. So in this case, we have an app store, and this app store receives some props. And these props are coming from the app store provider mounted in the React component tree. And it gets a user. So that means that higher up in the component tree, we have been running some logic related to a session. We've probably been waiting for the session state to change to authenticated so that we have access to a user and we mount our application. What's nice about this is that these stores, they work like hooks. So we can also go in and use the global store that we've defined higher up in the component tree, or maybe we just made it global, which impacts supports. What we do is that when we define our user here, we put the user into a signal. And the reason we do that is because we want to be able to observe changes to that user. In a signal, the value is immutable, just like useState. You have to change the value for observation to trigger. Next, we go and we grab some notifications. And this is actually a promise. So signals, they allow you to put a promise in them, and the promises becomes observable. So you can use them with suspense and the use hook, or you can actually observe the promise itself by looking at its status. Since this store is mounted in the React component tree, you're also able to run logic when this store is discarded of. So the cleanup function takes a disposing function that will run when this app store is unmounted. And in this case, we subscribe to user notifications. And when we get those updates, we update the notifications with this new value. And what's interesting about this is that this signal is a promise. So when we want to update that signal, we update it with a resolved promise. So it's always considered an asynchronous value. On the next line, we subscribe to user updates, and we can just pass the user signal here, because calling the user with the value is what sets the new value of the signal. And then what we do as an exposed API of this store is to return the user and the notifications as getters. So that means whenever a component points to the store user or the store notifications, it unwraps the value and returns it directly, and doing so also observes that value. So from a component perspective, as I mentioned, we have this App Store provider that's mounted somewhere in our component tree, which gets the user as a property. And now in the component, we are able to consume this App Store. And the way we consume it is using a new feature of JavaScript called Explicit Resource Management. And the reason we use that is because it's the least intrusive way to observe inside the component. So you don't have to import any observation function or anything like that. You just use the using keyword. And I know about the meme about using, and I'm sorry that we're kind of becoming an example of that meme. But it makes a lot of sense that you're consuming the store as an observable resource. And when the component function exits, you don't want to observe that store anymore. So it's the perfect use case for explicit resource management. And as you can see, we're consuming the username or the user here, which means that whenever the user changes, this component will reconcile. Now going into the notifications, we have these notifications. That's actually a promise of notifications. We could have used the use hook here and use suspense, but we chose to use just look at the promise itself. So whenever the promise changes its state, that will also trigger reconciliation in this component. So we look at the notifications promise status, and if it's pending, we'll return some loading state. If it's rejected, we'll have access to the reason for it being rejected. And when it's resolved, we have the value and we can list the notifications to the user. So there's, of course, more to learn about impact, but this is the gist of it. It's really like the novel approach. I wouldn't say like this is nothing unique. Like through all time of doing UIs, we've always had some concept of a controller layer, right? Even back in AngularJS, like AngularJS was very popular because you could just go into your HTML and you could say ng controller, and you would get a class where you could define observable primitives and do state management. And this is what really context allows us to do, but it's tied to the reconciliation loop. So we just drop out of it completely. And we can't do that. We can't only do global and local. We really need to think of global as just the outer scope of state management. We need to be able to do complex state management through our application as well. And this means more now with React 19, having these asynchronous patterns with the use hook and suspense and so on. So if you're curious and want to learn more, go to impact-react.dev and please give feedback, ask questions, and thanks for listening.